Hello all, welcome to Soumya's Tech Talks. In today's lecture, we will discuss on shared pointer in C++. Today we will discuss below topics. First we will give some introduction about shared pointer, a deep dive into shared pointer, how it is internally implemented and managed, and advantages, and we will discuss with some example programs. Let's start. So shared pointer is it's also like a unique pointer uh, we discussed earlier, which manage the objects allocated on the heap. So, but there is a difference between shared pointer and unique pointer. So unique pointer you cannot have shared ownership, like you cannot create copies of unique pointer which is pointing to same memory. Only thing is you can transfer the ownership to a new unique pointer. But shared pointer is not like that. You can have multiple copies, means multiple shared pointer copies can refer to same object on the heap. And it maintains a reference count, how many copies of shared pointer was created, or how many shared owners currently exist. So whenever the shared pointer copy is destructed, or when it is goes out of scope, the shared pointers destructor will be called. It will decrement the reference count. It will wait until all the owners, all the shared pointers copies are destructed, means reference count is 0. Once reference count is 0, it will free the object, original object which is managed by it. So shared pointer is, as the name suggests, it is shared ownership. Like you can have multiple copies of shared pointer which is pointing to shared memory. We'll discuss in more detail. So here, uh, as I discussed, let's see. You have a class called my class. I just created for. It has a integer data. So this is the sample class. Let's see how to create a shared pointer using for this class. So you can see, read the comments. So I have created a shared pointer for this class object on heap using make shared, and I am passing whatever the integer required for the constructor of my class. So in the next line you can see I am creating multiple copies, like P1 is the original shared pointer which is created. From there I am creating multiple copies of shared pointers. You can also pass to a function directly, but in unique pointer it is not allowed. In unique pointer you only can do is transfer the ownership. Like you cannot pass this unique pointer directly to a function, or you cannot create copies of it. Only thing is you have to transfer the ownership. It means only one owner is exist to manage the object created on the heap. But shared pointer, it is, you can create, as the name suggests, it is shared. Like you can create multiple copies of shared pointer from the original shared pointer. You can also pass to a function. So whenever you do this copying, the reference count will increase, and whenever here it is a use count is reference count. So once a shared pointer is out of scope, goes out of scope, or it is reset, then the destructor of the shared pointer will decrement the reference count. And once the reference count is 0, the original object, here in case my class object, original object which is being managed will be deleted. We will see in shared pointer, uh, in unique pointer it only have the pointer to the original object which is managed, but in shared pointer it needs additional memory for the control block. Whenever you create a object using the shared pointer, so there are two things happens. One is the memory for that object will be created, and also a memory for a control block. You can see the control block looks like this. It has a strong count. Strong count means how many shared copies created for the shared pointer. It will maintain in the strong count, and weak count we will discuss it later when we talk about weak pointers or weak references. So strong count is how many shared pointer copies created, and you have a custom deleter like we discuss in as part of unique pointer. You can have a custom deleter which will be invoked when the shared pointer wants to delete this object, the object being managed. Instead of deleting it directly, it will use the custom deleter. It will invoke the custom deleter which is provided by us. So there we can take care of deletion and freeing up the memory in the way we want. So here you can see control block as a constructor and destructor. In the constructor you will receive a pointer and the custom deleter. A custom deleter also will be provided. We will see the constructor of the shared pointer. So here you can see the picture. Whenever you have a shared pointer, unlike unique pointer which is holding a pointer to the original object, shared pointer also have the control block. Control block of it is a templatized. So template is same as the object type. So object type is let's say my class, the control block also of my class. So both are created on the heap. You can see object is created on the heap. Additionally, control block also created on the heap. This is one limitation of shared pointer because it is consuming extra memory for this control. So here object of type T is the object which is being managed by shared pointer. Control block just keeps the metadata like weak count, reference count, custom deleter, all the things will be inside the control block. So here if you see the internal implementation, let's focus on the constructors. Like you have a constructor and you have a copy constructor, or you can also have the assignment you can do. So if you see the constructor, it will receive a pointer to the original object. So basically it has two member variables. One is pointer to the original object, one is control block. So first in the constructor it will create the control block, like control block will be created using new control block. So where you will provide two arguments, one is P is the pointer to object being managed, and here the custom deleter. Here in case it is just giving a lambda function, the lambda function just deletes the object using the delete. We can also in the shared pointer constructor itself we can pass the custom deleter like we did in the unique pointer. Okay, so that instead of directly deleting, it will invoke the custom deleter. And if you see the copy constructor, what is happening here? So here it is just incrementing the strong count. Whenever you are copying a shared pointer, so you can see here example, I have created one integer using the shared pointer, and I am copying it from I am creating a new shared pointer, copying from the existing one. So whenever you create a shared pointer using the existing one, or you want to create a copy of or another reference to the object, so in that case copy constructor will be invoked. So it just copy the pointer and the control block, and control block is shared by all the objects, all the shared pointer copies created. They all share the common control block. Inside that the strong count will be incremented every time whenever you do a copy. So this is the constructor side. You have a constructor and you have a copy constructor. If you see the destructor side, so in the destructor it is called release function. Here what they will do? So this destructor generally called whenever a shared pointer copy, let's say a shared pointer created is goes out of scope or reset is called. Okay, in that case the destructor of the shared pointer will be called. So here it will decrement the count, strong count means it will decrement the strong count. So if the strong count is 0, then it will invoke the custom deleter. And this weak reference count, if the weak reference count also 0, it will also delete the control block, otherwise it will keep the control block alive. We will discuss this weak reference count when we talk about the weak pointer. Weak pointer is generally created from the shared pointer. So this is the destructor side. So today we will end the this lecture on shared pointer. So there is lot of things to discuss on the shared pointer. It is a huge concept. So we will continue more lectures on this followed by this. Thanks for watching for today, and please share this video to your friends. Bye for now.